Hello, my dear students. Myself S. Devi, Assistant Professor, Department of Artificial Intelligence and Data Science, Rohini College of Engineering and Technology. I am here to handle data structure using C++. Today, we are going to discuss about the topic QADT. We will see what is Q. Q Q is a linear data structure in which follows the concept of FIFO. Here, the insertion and deletion takes place in an end known as rear end, and deletion takes place in another known as front end. For example, waiting line in reservation counter, queue in a cinema ticket counter, scheduling of jobs in computer is an example for queue. The operation performed on queue are NQ and DQ. The process of inserting an element in the queue is known as NQ, and the process of deleting an element from the queue is known as DQ. To insert an element X onto the queue, the rear is while inserting an element in the queue, the rear end gets incremented by 1. When deleting an element from the queue, the front end gets incremented by 1. Initially, the value of front and rear will be set to -1. So, in the case of first insertion, the front value and rear value gets incremented by 1. So we are going to implement the queue concept in an array. So you know that the starting index of the array starts from 0. So if the maximum capacity of the array is 5, means it ranges from 0 to 4. And we have to consider two concepts there, queue underflow and overflow. So while performing the deletion operation, we have to check the condition that whether the queue is empty or not. Before performing the deletion, we have to consider the condition that the queue is empty or not. While inserting the element into the queue, we have to check whether the queue is full or not. If the queue is full, we cannot perform the insertion operation. That is, if the maximum capacity of the array is 5, we cannot store the sixth element. And similarly, if the array is empty, we cannot perform the delete operation. If the array is empty, we cannot perform the delete operation. So, we have to check two conditions. Before insertion, we have to check whether the array is full. Before deletion, we have to check whether the array is empty. So, consider an example that we are consider the empty array. That is, in the case of empty array, there is no element. So, the rear value and front value will be set to -1. It points to -1. Okay, so when you insert one element, say 10, into the queue, what happens? The rear value and the front value gets incremented by 1. As I told you that always the front points to the first inserted element and rear end points to the last inserted element. Okay, so now what happens? The rear and front both points to the value 10, the index 0. Okay, next now we are going to insert another one element, say 15. So what happens when we insert an element? What happens? Automatically the rear value gets incremented by 1. So the front points to the first inserted element, the rear points to the last inserted element. Now we are going to perform the DQ operation. DQ means deleting an element from the queue is known as DQ. So when you perform the DQ operation, what happens? By default the element that is pointed by the front will be deleted first. Next, after that also we perform a DQ operation. What happens? The element that is 15 will be deleted. The element that is pointed by the rear will be deleted. Now what happens? The queue is empty. So both front and rear will be set to -1. After this coding for NQ operation, so as I told you that we have to check whether before insertion we have to check whether the array is full. If the array is full, we have to print an error message that the queue is full, so that we cannot perform any insertion operation. Otherwise, we can perform the insertion. While performing the insertion operation, we have to check whether the front is equal to -1. If the front is equal to -1, what happens? The front value should be incremented by 1. Otherwise, no need to increment the front value. Okay. So when you insert an element, what happens? Automatically the rear value gets incremented by 1. When you delete an element, what happens? The front value gets decremented by 1. So in the case of DQ operation, we have to check whether the array is empty or not. If the queue is empty, we cannot perform the deletion. So we have to check whether the front is equal to -1, or otherwise the front is greater than rear. If it's so, what happens? The queue, we have to print an error message that queue is underflow. So that is queue is empty. Okay, otherwise we can perform the deletion operation. Always we have to delete the element which is by the front. The advantage and disadvantage of the queue. Advantage is it is easy to implement. Since we are using the array concept, it is easy to implement. It is fast in processing because of the continuous memory location. No extra memory is required for the pointer. Suitable for small and fixed size queues. Disadvantage is fixed size cannot be increased during the execution. Queue overflow occurs when the array becomes full. Memory wastage if the queue is not fully utilized, not suitable when data size is unpredictable. The application is CPU scheduling, printer spooling, keyboard buffer. This is all about the queue concept. We will see the next concept in the next section. Thank you.